Hello, welcome to my channel. I hope you find the video interesting, and if you do, please, I invite you to subscribe. Today I want to talk to you about a thing that I've been hearing a lot, and it's this phrase: it doesn't matter, it's just a theory. It's not something that has been proved. So many people now, even if they don't have any formal studies in any particular discipline or something, when you talk to them about it, about any subject where you have been studying, or when a scientist talks to them about a subject they've been studying, they come back and say, well, that's your opinion, but it's just a theory. It has not been proven. So I wanted to talk to you about this because I think it's something really important for everybody to understand what a theory actually is. And we're going to go by saying what are the requirements that something has to have, to comply with, to be called a theory. So a theory begins with describing something. You make a theory about a kind of thing. You can make a theory about a kind of happening, like when you throw stuff into the air, it falls back down. That would be some type of event. And you make a theory about not just this one event, but all the events of the same kind. So to begin with, a theory has to describe very precisely and very objectively a type or kind of thing or phenomenon. And it has to do it in a way that it will be a good description for all the examples of this kind of thing, but it will not fit any objects from a different kind. So that would be a first requirement. The second requirement is that it has to be more than just a description. It has to be an explanation, which means it has to tell us how each element of this phenomenon relates to one another to produce effects. So this is very important because when we know the way the elements of a thing relate to each other to produce effects, we can start making predictions. This means that when I see how things are right now, I can tell how things are going to be later. For example, once we learned about heat and water, we can see water that's been heating in a stove or something, and we can use a thermometer, and then we see the temperature is rising. So we can predict that clean water at sea level will start boiling once the water reaches 100 degrees Celsius. So that's what I mean by predictions. So theories are all about explaining stuff in a way that allows you to make predictions by looking at the way things are right now. You should be able to tell us how they are going to be later on. And from here, we go to the part where you say, this is not proven, this is just a theory. Because as theories have to be able to make predictions, science makes a very clear distinction on any explanation when it has not been proven, when it has not made predictions that have been observed to be true. This is not called a theory, this is called a hypothesis. It can only be called a theory once this explanation has been put to the test. Once the people who have proposed this explanation made predictions and observed that these predictions were accurate. But not just that, it's required that other people independently make the same kind of predictions and observe that they become true. So, whenever somebody talks to you about a theory that explains something, you have to be confident that this means this explanation has been proven. Otherwise, it would have been called a hypothesis. And theories can only get it wrong one time, because whenever a prediction does not come true, science demands that the theory should be improved, modified, or even discarded. So, that's it for today. I hope we got to an understanding. Theories are always explanations that have been proved. And from now on, I hope you have that to your advantage when you're trying to find answers for your questions. And please, if you like the video, subscribe to my channel, and I hope to see you next time.